Hey everyone! Welcome back to ZoomInData. And this is episode 18 of our KQL Concepts Deep Dive series. Today we are exploring the philosophy behind aggregation functions, the trade-offs between exact and approximate results, especially count versus decount. We are keeping everything pure concepts and interview focused. If you missed episode 17 on grouping mechanics and cardinality risks, it's a great one to catch up on. Let's get started. Here is our roadmap for today. Exact aggregations like count, sum, and AVG return precise results. Approximate aggregations like decount and approximately _count_ distinct trade accuracy for speed and scale. Hyperlog algorithm powers decount, probabilistic counting. Approximate functions shine on high cardinality or massive datasets. Choice depends on precision needs, data volume, and performance goals. Understanding exact versus approximate prevents over-optimization or under-precision. Let's dive in. Let's start with exact aggregations. Count counts every single row, no approximation, always exact. Sum, AVG, min, max, compute precise values over all rows in the group. Exact functions are deterministic and always correct. Their cost scales directly with row count, full scan required every time. Use exact aggregations when data volumes are small or when legal, financial, or compliance requirements demand absolute accuracy. Precision is non-negotiable here. Now the approximate side. Decount and approximately _count_ distinct. Use the hyperlog algorithm for probabilistic counting. Error is typically around 1 to 2% with extremely low memory usage. Speed and memory scale logarithmically, perfect for billions of rows or high cardinality data. They are ideal for counting distinct values like unique users per day or IP addresses in logs. The philosophy is simple. When you're dealing with massive scale and trends matter more than exactness, approximation is not only acceptable, it's smart. Use it for monitoring, dashboards, and exploratory analysis. Check out this quick trade-off diagram. It shows why KQL gives you both exact and approximate aggregations. On the left is exact count, precise number icon, full data scan arrow, and a tall high memory bar. It reads every single row, computes the true count, 100% accurate, but it costs a lot of memory and time on big datasets. On the right is approximate decount, hyperlog sketch icon, tiny low memory bar, and a lightning bolt for speed. It uses probabilistic magic to estimate the distinct count with just 1 to 2% error. Super fast, super low memory, perfect for billions of rows. The middle divider says exact versus approximate trade-off, with the scale icon balancing precision on the left against scale and speed on the right. The philosophy is simple. Use exact when every number must be perfect, billing, compliance. Use approximate when trends and speed matter more than the last digit, monitoring, dashboards, large-scale analytics. Choose wisely, and your queries stay fast without sacrificing too much truth. How does hyperlog actually work? It's a probabilistic data structure that estimates distinct count without storing every value. It uses hash functions to map items into buckets and tracks the maximum rank, longest run of leading zeros in binary. This gives a very accurate estimate with tiny memory, often just a few KB even for billions of distinct items. Error is tunable. More memory means lower error. And within the same sketch, estimates are deterministic. Same data gives same result. This is why decount is so powerful at scale. Massive distinct counts with almost no memory cost. So when do you choose exact versus approximate? Use exact count for small data volumes, billing calculations, or compliance reporting where every unit matters. Use approximate decount for large-scale monitoring, dashboards, and trend analysis where 1 to 2% error is acceptable. Approximate really shines when cardinality exceeds millions and you need sub-second responses on billions of rows. Never use approximate for financial totals or exact row counts. Precision is mandatory there. Smart pattern. Combine both. Exact on filtered small sets, approximate on raw large sets. That gives you the best of both worlds. Look at this simple decision tree. It's your quick mental model for choosing between count and decount every time. Start at the top. Need exact precision? Yes. Green path straight to count. Perfect for compliance, billing, financial totals, anything where every single number must be 100% accurate. See the compliance, billing icon. That's the use case. No. Keep going. High cardinality or large data? Yes. Blue path to decount. Approximate counting with hyperlog, super fast and low memory even on billions of rows or millions of distinct values. Monitoring, trending, dashboards. That's where the scale winner icon shines. No. Back to count. Still exact, but safe because the data isn't massive. This little flowchart captures the whole philosophy. Exact when precision is non-negotiable, approximate when scale and speed win, and most production telemetry falls into that approximate bucket. Use this mental model, and you'll never overpay in compute or underdeliver on performance again. Why does this topic matter in interviews? Interviewers test scale thinking with aggregation questions. Common questions include, when would you use decount instead of count? And, explain hyperlog. Understanding exact versus approximate shows production awareness. This topic is critical for monitoring, telemetry, and big data roles. Explaining trade-offs demonstrates optimization mindset. Nail this, and you prove you can build systems that handle real scale without wasting resources or sacrificing too much accuracy. To wrap up, exact aggregations like count and sum give perfect precision but scale linearly with row count. Approximate aggregations like decount give about 1 to 2% error with logarithmic scale, massive speed and memory savings. Hyperlog enables distinct counts on billions of items with tiny memory. Choose based on precision needs versus data volume and performance goals. Approximate is smart for monitoring and trends. Exact is mandatory for billing and compliance. This exact vs approximate philosophy is one of KQL's superpowers at scale. That's episode 18 done. Thanks for spending time with me on ZoomInData. Next in episode 19, hyperlog, HLL, algorithm, we will do a deep dive into probabilistic counting theory and how it powers decount. Homework to lock this in. Explain to someone or out loud. Why use decount instead of count in KQL? Think of a dashboard where approximate count is acceptable. Answer this one. What is the main trade-off with approximate aggregations? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 19, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.